So before we're able to do the problems that we're going to do today, you need to have some understanding of the graph of a quadratic equation or a quadratic function. Sometimes I'll say quadratic function, sometimes I'll say quadratic equation. Those are exactly the same thing. If you remember early in semester 1, we talked about what it is for what a function is, how we check for something is a function, and then the idea of using function notation. So our quadratics that we've been factoring, solving using the quadratic formula, or even the whole idea of greatest common factor, those graphs, they form something called a parabola. So the graph of a quadratic function, and we write a quadratic function, I wrote it in the form we've been looking at, y equals ax squared plus bx plus c, or you can put it in function notation. Remember, that's just a fancy way of showing that it is a function. F of x equals ax squared plus bx plus c. And that whole idea that a, b, and c are just numbers, they're constants. And you use those in the quadratic formula. So the graph of a quadratic function is something called a parabola. And it either looks like a right side up U or an upside down U. So how do we know if that parabola is we call it opening up if it faces up, or if it opens down if it's facing down? Well, some characteristics of parabolas that you need to know are as if A is positive. So if this coefficient on the x squared, the number out front, if it's positive, that tells you that your parabola opens up and it's going to look like a U. If A is negative, that tells you that your parabola opens down, and I always say it looks like an upside down U. If you put 0 in for x, well, in any quadratic equation that's in standard form, if we put in 0 for x, these first two terms drop away. So we're just left with c. So when x goes in, c comes out, so we get the point 0c on our graph. Well, anything that has an x value or x coordinate of 0 is our y-intercept. So we can always get our y-intercept if our quadratic is given to us in standard form. And then what we're going to be doing in our problems today, or part of what we're going to be doing, is finding the x-intercepts. And the x-intercepts are when y is equal to 0. Well, that's important in a story problem because a lot of times we're looking at things that are being thrown into the air. Maybe we're shooting off a rocket, maybe we're throwing a football, and we want to know when does it hit the ground. Well, if something is 0 feet above the ground, that makes sense that it's hit the ground. So we're going to be setting those quadratics equal to 0 and solving. Well, and that's why, before we could do story problems about it, we needed to make sure we could factor a quadratic, and we need to make sure we can use the quadratic formula. So those two methods are going to be super important when you're trying to find, sometimes it's called the zeros, sometimes we call it the solutions, sometimes we call it the roots. But all of those are words that we can use for the x-intercepts. Then the last characteristic we need to talk about is this idea of a vertex. So the turnaround point is called the vertex. It's the highest point or the lowest point. It's what's right in the middle of the U, if you will. So if the parabola opens up, so if A, your leading coefficient, is positive, your parabola is going to open up. And this bottom point is called your vertex, this guy right smack dab in the middle. And it would be the minimum. So does it make sense if our graph is opening up? This is the smallest value, the smallest y value our graph would ever take. So it's a minimum. If your parabola opens down, so that means that A, your leading coefficient, is negative. That means we're going to get this upside down U. That means the vertex, this point right smack dab in the middle, is a maximum. So a lot of times these are the ones we're going to look at in our problems because we're maybe throwing a football. Well, if you throw a football, it doesn't go under the ground and come back up. You stand on the ground, you throw a football, hopefully not like this. Maybe you throw like a girl, I don't know. But you throw a football and it comes back down to the ground. So we'll be looking for the maximum height or the maximum distance. So that's going to happen to us a lot. And the way that we're able to find this idea of a vertex is we can find the x coordinate using the negative b over 2a. Well, b and a are just in That's standard form of a quadratic, so you just pull those values straight out. This negative b over 2a gives you the x-coordinate of the vertex. And then to find that minimum or maximum, depending if it opens up or down, you plug this number in and see what you get. That might sound a little confusing, but we're going to do some problems with it together here shortly. But I need you to understand what the whole idea, when I use the words in the next videos, parabola, vertex, x-intercept, y-intercept, roots, I need you to understand what those mean. So I wanted to talk about the parts of the graph first.